Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one is entitled Spherical Earth, Measuring the Earth's Radius. There are people living on Earth right now that seem to be confused as to whether the Earth is flat or spherical. The educational system should have remedied this a long time ago by simply teaching the facts correctly, but this has clearly not been done. In fact, such erroneous beliefs seem to be encouraged through an educational system that teaches people that knowledge is relative and the two opposing views can both be correct, which indicates that the powers that be would like people to be confused and not be able to think clearly. This may be because the real sun, moon, and planets have been replaced in the sky by simulators and holographic projections. And you may look at Article 226b entitled Sun Simulating Devices, the Irrefutable Evidence, and Article 293 entitled The Fake Blood Red Moon of July 27, 2018. And that it was done for the purpose of hiding what is going on in the solar system and the objects that are affecting the Earth, and causing it to be in a state of a slowly developing cataclysmic event. And you may look at Article 282 entitled Earth in Upheaval, Magma Rising from Beneath. A confused public who think it is possible that the Earth is flat and that the Sun orbits the Earth at a close distance are not inclined to realize that they are being deceived. Now, the Greeks knew that the Earth had to be spherical by the 3rd century BC, and the Greek scholar Eratosthenes, who lived between 276 and 195 BC, calculated the Earth's circumference with some accuracy. He could not have done so if he had not understood that the Earth was a sphere. Eratosthenes was living in Alexandria at the time in Egypt, but he knew that the sun was directly overhead at midday on the summer solstice at the town of Syene, which was about 800 kilometers south of Alexandria. He knew this because the sun shone right to the bottom of a well at midday in the town of Syene on the day of the summer solstice. The reason why this occurs is because the town is on the Tropic of Cancer, where the sun is directly overhead at midday on only one day in the year, June 21st, or the summer solstice. Now, the summer solstice is a time when the sun is actually the northern part of our planet is receiving more sunlight than the southern part, the southern hemisphere. And this occurs because, first of all, the Earth is spherical, the Earth orbits the sun, and the Earth's axis are tilted by 23.5 degrees. And the Earth maintains that orientation always, that orientation with respect to space. So what happens is, as it moves in its orbit, its position changes with respect to the sun, and therefore that tilt in the axis means that certain parts of the Earth will receive more sunlight than others. So here we are at the winter solstice. As you can see, the North Pole is tilted away from the sun, so this is called the winter solstice because it's winter in the northern hemisphere. The North Pole is not getting any sunlight, and the northern hemisphere is getting less sunlight than it does at other times. And in fact, the winter solstice, December 21st, is the time when the North Pole is most tilted away from the sun. And then as the Earth orbits around the sun, we get to the spring equinox, which is on March 21st. And at that time, the axes are in such a position that both the North and the South Pole are getting exactly the same amount of light. So the Earth is on its side, but directly facing the sun. So the equator, which is the latitude line running through the center of the Earth, is now in line with the ecliptic, and the ecliptic is the plane in which the Earth orbits the sun. And so the ecliptic plane would be the plane that is defined by actually the circle that we see here. Well, it looks like an ellipse, but it's a circle. And what we have then is that the equator is crossing the ecliptic at that time. Then as the Earth orbits a bit further, it eventually gets to the summer solstice. And at the summer solstice, the Earth's axis are in such a position that the North Pole is tilted at the maximum angle towards the sun, 23.5 degrees. And that means that the latitude line, which we call the Tropic of Cancer, and here we see it here, is touching the ecliptic plane. And so this is the Tropic of Cancer. And so any point on that line, when it reaches its midday position, where it's directly facing the sun, will be in such a position that the sun will seem to be directly overhead. So the sun is directly overhead any point on this line on this day. And then after that, the North Pole starts tilting away from the sun, and eventually you get to this position, and that is the fall equinox, where again the equator is facing the sun and the equator is now crossing the ecliptic. So this is illustrated here again, how on the summer solstice the sun's rays are directly above a point on the Tropic of Cancer. So if we draw a tangential line here, it will be exactly 90 degrees to the sun's rays. Now, so Syene is on the Tropic of Cancer latitude line, but Alexandria was not on the Tropic of Cancer, it was further north. So Syene was here, and Alexandria was on the Mediterranean, further north. And so the sun was not overhead for Alexandria, and therefore if we had a pole that had been struck vertically into the ground at Alexandria, it would create a shadow on the ground. And then from the ratio of the length between the length of the shadow, and you can see it here, and the height of the pole, this angle here can be calculated. But this image then illustrates how the sun is directly overhead, so a pole at Syene does not create a shadow. But a pole at Alexandria, because the sun is now not directly over Alexandria, the sun makes an angle with the ground that makes this pole create this shadow. In fact, that angle is, well, this angle here is 7 degrees. So this angle was calculated by Eratosthenes. Nowadays we can just use a bit of trigonometry, and we know that the tangent of this angle is the opposite over adjacent. So it's this divided by that. And from that, if we know both lengths, we can calculate the angle. Then with our knowledge of geometry, we know that this angle is the same as that angle because these two lines are parallel. These are the sun's rays coming in from the sun. So this angle is the same as that angle. And what the way Eratosthenes figured this out was he realized, he measured this angle, he knew this angle was about 1/50th of the size of an entire angle. I mean an entire circle. A whole circle has a total angle of 360 degrees, and 7 degrees is about 1/50th of that, and we can figure that out by taking 360 and dividing by 7. We get 51.4, so that's very close to 50. So what he did was, now he knew that this is the angle that subtends the arc length between Syene and Alexandria, and he had this distance measured, and in today's units it's 800 kilometers. So that means that if the size of this arc between here and there, which is 1/50th of a whole circle, is 800 kilometers, that means that the total length of the arc for the total circle, which is the Earth's circumference, would be 50 times 800. And when you multiply 800 by 50, you get 40,000 kilometers. And then this is actually very close to the circumference of the Earth, but we can go further and actually calculate the radius of the Earth, because we know from this formula that the circumference of the Earth is 2 pi times the radius of the Earth. So the radius of the Earth would be 40,000 divided by 2 pi, which is 6,366 kilometers. And this is extremely close to the current accepted value of 6,371 kilometers. So his result was extremely accurate for the time. So in conclusion, the Greeks knew over 2,300 years ago that the Earth was not flat but spherical, and Eratosthenes was able to use his knowledge of geometry to correctly calculate the Earth's circumference. He also devised a way of determining position on the surface of the Earth using a system of longitude and latitude, and also a calendar which included leap years. And here are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.